got maybe a better idea. Why don't we do a code kata? And maybe what we can do is we can, because then at least I will be coding something. I'll do new window. We'll be doing some coding, so at least that's good. But maybe the idea is let's do them in 2 languages, so one in Kotlin and one in Elm, and we'll have the tests working, etc. in both languages, and then we can see how they compare at the time. What if we do that? Why not? It's also content. Don't judge me. So I think we will try to do my favorite one, which is the Mars Rover kata. The rover test. Yeah, add it. I don't care. Okay, so first of all, let's write a test. Something that a rover can have a position 0, 0. This might not work. And a facing direction north or something. Nope, that just works nice. Okay, cool. And then if I run this, it should work. Maybe I should have put an assert in there. Assert that true is equal to false. Well. Okay, and as that is going, I think what I want to do is put, where was that here? Get rid of that stuff. Maybe we open a new directory somewhere. Okay, get rid of that. Well, we can open a new tab. So if we go to there should be a code retreat Elm, kijk eens aan. And I believe if we do, we already have an npm install. No, we should do npm install, I guess. Let's try it anyway. This one might be out of date a little bit. Seems like we've got Elm 19.1. Yeah, no one cares about that for a local thing, I guess. And then we just do npm test. Oh, this already contains some implementation apparently, because it has rover and move and not, etc. And maybe what I also want to do is stop that and then open this in Visual Studio Code, I was gonna say, but apparently that's not gonna happen like that. So we file open we open the code retreat Elm directory. Hopefully it'll, oh yeah, nice, it's opening in a new window. That's great. Yeah, sure. Or do I want to do that? Maybe let's do that later. And then I want a console. I don't remember how to open that thing, but I do remember that there's like a general shortcut. Terminal, new terminal. Look at this. Look at this, man. Now we can do npm test, and it will be watching, I hope. And then instead of the tests that we already have, we can just skip all of this crap and then just say expect true and then false. Want to become famous, but I've always wanted to become famous. That's such a great idea. Pay attention to none of that stuff. We don't care. We also don't care at all about implementation. I think that's it. And then we save. Ha! And we expected false, but we got true. I think we're good to go. There's nothing in here. Yeah, a bit. We've got world and Elm. That's just a simple example. All right. Oh. Okay, so this is going to be our first test. So a rover can have a position and a facing direction. Let's try to implement that. So what we can do is we say, if we create a rover, so let's say that this is something that's going to create us a new rover. Then we can assert that this rover is of a type rover that has a position 0, 0. So we can do it like this. And a facing direction called north. Yeah, I mean, this is just part of, how do you say that? A direction system, and it will only have a specific amount of options that you can have there. So let's add that. So a direction is an enum class called direction, and it should at least have north. This we can import. And then a rover should be some other class that then has two properties. One is X and one is Y or something. Val Y. And then a facing direction, which is a direction type. Nice. Now rover doesn't exist yet. Oh wait, this also needs to be a val. So if we do function rover should return a new rover, then we say let's return a rover with 0, 0 and then also north. Let's run the test. Oh shit, no tests were found. That's because it was an internal function, probably. Man, we've never seen a rover fail, huh? Or this test fail. Oh, here we go. Here we see it fail. Why is it failing? Because rover cannot be compared. It's not a data class. So now, because I added data, we've got an equals and hashcode implementation for free. And we even have a toString for that as well. And once this test runs, voila, it's green. Let's make it fail. I'll show you what it then would look like. So this would be, voila. Now you can see why it's failing, in fact. So here's our implementation. It seems to be working. Let's try to improve on the code a little bit. you can already guess we've got a position 0, 0. Currently we're just passing those two things as a separate thing, so both are integers and you can pass them separately. I don't want that anymore because it's representing one concept. So what I want to do is transform that into a new type. Let's call it position, where we say 0, 0, and then we should also try to change our test accordingly. Then yeah, we'll need a new data class position, which then takes both of these integers, and this should be a position. Okay, so we've done our refactoring. Just change those two XY parameters or values of a rover with a position class, and it should still be running green. And then maybe the other thing we can still do is these sound as defaults, or they look like defaults. So what I want my code to look like, in fact, is to have it look like this. So then I can say, well, if you don't pass a position, in that case, your rover is situated at 0, 0, and you're facing direction north. This should also still work. Noise, and then maybe finally what I want to do. Yeah, now we can just inline this because it doesn't do anything. Voila. Maybe I want to have a shorthand for this position, like the creation of a position. So let's create a function called at, which also takes two integers, x and y. And it should just return a new position of x and y. And then we can just replace this with at, and this thing as well with at. There we go. Okay, voila. So that's the first test complete, refactor with all I wanted, I guess. In Kotlin, let's make the same thing in Elm. So can have a position and a direction. So what oh fucking hell. So this part here, I think false expect equal true. So it's the other way around. So this is the actual, I think. So let's call that actual, and then we'll do a let in expression where we set actual equal to false, and we save, and then we get still false expect equal to be true. Okay. Now the way it should look like when it's working, it looks like that. Nice. So our actual now should be a rover. So let's make another function called rover. We don't have that thing yet, but we want our thing to equal a rover with a position. Maybe we'll call that at immediately because we've learned now from our mistakes. And I think we can just have a tuple for that, maybe. I don't know. Does that work? 0, 0, just like that. At, and then that's the first argument. And then the second argument would be the direction. So let's call that north. And then this is the thing we expect against. So a rover would then be a type alias. And it will have a position. And the type of that thing will be a position type. And then the second part will be a facing direction. And this will be a direction type. And then we just have to declare what a position is. So I think we can say position. I'm not sure if I need to do a record type like that, because I think there's something called a tuple. Oh, that doesn't work. Damn, it's been a while, yeah. Voila. So now we say position is a tuple, I think. That should work. And then finally direction. That's an exhaustive type. So we'll say direction. You, good sir, can only be... Oh, fuck. You can only be north for now, because that's all we need. Voila. And then finally we need a function. Where we say rover is something that doesn't take anything, but it returns a new rover. And then we just say rover with position. Oh shit, that doesn't work that way, yeah? So then we just say 0, 0, I think. And then we say north. So this is the definition. And then this is not compiling. Why is that? Oh yeah, okay. Yeah, we need to int type alias then still. Voila. Okay, I was right with the type alias shit. Okay. Voila, and now the only thing that's lacking is the @. Yeah, maybe let's not have it compile, or not have the test work. We probably don't need the @ here. I mean, this looks good enough, I think. Excuse you? Mayon, are there tests in any Elm file? Yes, we had been running them all this time. And it seems to be compiling at least, so it's too bad, huh? Let's try running that thing again or something. Are they exposed? Exposed? Everything is exposed, apparently. And now it's just not working because two different types. Tjonge jongen. I wonder why that is. Ja, allee, kan dat nu? We had failing tests before Mayum. Okay, maybe we just want to expose suite then or something. Oh, voila. Okay. It's probably because it tried to expose everything. Maybe that's the reason. So let's try this. Yeah, expected and then actual. Okay, tests pass. Let's make it fail. Okay, that's great. I do want a more specific type for position, I do think, because now it's just an alias for two integers. Don't really know, or a pair of integers, I should say. How can we fix that? Sure. If it's a record type, then we at least have something more obvious than just a tuple. And then in that case, we need to say that it's a position of 0, 0. We need to also fix that here. And then we'll need to do some more magic with the parentheses. Voila. Yeah, here we don't need these anymore. And then maybe what I wanted to read a little bit better. I'm not sure if it will be readable or more easily readable, but there is a way where you can say I want to construct a rover yeah, I'm not sure how to do it, but you can do some magic with piping, where you say this is something I want, and then that. No, that even doesn't work yet. Why not? Found a function that takes a direction to transform into a rover. Yeah. So if we do north and we pipe that into this block, I guess. Well, that doesn't look very good. And I don't think we can do this either, right? What if we switch them around? So if you first put facing position and then the facing direction and a position, at least this looks a little bit better, because the direction will never take another argument, but position does. Yeah, so maybe let's try to do it like that then. So then what we're really saying is we're transforming this position of 0, 0 into a temporary constructor of a rover that already has its direction north. It's a little bit better, I guess. Yeah, you tell me. Yeah. Okay, we saved and it's working. Great. Then, yeah, let's add another test in Elm maybe then. Can receive messages or commands, I think. Yeah, but that's like a little bit silly, yeah? Maybe we need a separate thing for that. So describe when receiving forwards. And now we need to say, oh shit. No, describe takes an array. So it should look like that. And then we need this kind of a block. I think I might have, no, this is good. And then these need to be on a different tab. So when receiving forwards and facing north, then returns a rover with increased Y position, something like that. Okay, so when we do, so now we need to say receive forwards as a new function on a default rover. So that would be this one. When we do, then this is X, this is Y, so it would be like that. And still facing north, huh? Then receive forwards doesn't exist yet. So receive forwards is a function that takes in a rover and returns a new rover. And then as an implementation, we'll just say, just return the rover or the existing rover. Yeah. So this is a function already. I think I'm going to favor renaming this one. Is that a thing we can do? Rename? Rename symbol. Default. Oops. Rover. There we go. That's better. Voila. This should fail. Great. Yeah, now we need to just bump a new rover. So that's saying, oh yeah. This is, I think, how you update stuff. So position, I believe it was called. Yeah. Yeah. New position. And then new position is something that we will write in a let expression. Just make it compile first. Voila. Basically now we want to say, I want a new position. Does it work like that? I don't think it does. No. Now we need to get a rover's position, I think, and then update it. How do we go about doing that? I forget if you can destructure a type alias or a struct into these things. Doubt it. Now then I think we can only try to make something for this. So that would be get position for a rover. So that would be old position equals this thing. And then we just say old position, and there we just update y. Then get position doesn't exist yet, so let's try to put that closer to position, shall we? Speaking of which, let's move receive forwards also closer to rover. Huh? And then get position. Oh, that should be on rover as well, I guess. But it's less important, so let's put it here. Get position for a rover, well, gets a rover and returns a position. And get positions implementation for a rover. I think I can do that. You can do the structuring. Yeah. Okay. I guess we could have destructured that here as well then, huh? No, let's leave it for now. We just have the function. Oh, you cannot do that. I know this, but I don't care about the facing direction. Ah, yeah. You don't need to declare what the other things in the record are. Hey, but we've finished a test, huh? Can we still refactor some stuff? It's already looking weird. So no. I feel like we can... If we have a set position again or something like that, that returns a new rover, then this would be set position. But what good would that do us? No, I think I will leave it at this, and then maybe later we will receive new insights. So back to Kotlin then. Here in Kotlin, we've got a new test. I forgot already what it was here. No, this we don't need, I don't think. When receiving forwards and facing north, then returns a rover with increased y. When receiving forwards and the rover is facing north, then y is increased or something. Okay, so we'll start off with a default rover again, and then we'll assert that when we do rover.receive forwards, just to keep it in line, we'll do is equal to new rover at x, well, 0, 1, and still facing direction dot north init. Okay, so let's just apply the same style. So let's return an immutable object for a rover on receive forwards. It's already a data class anyway. So let's add this member function then. Yeah, this is a bit silly, yeah? IntelliJ. Voila. And we can just return this just like we did in Elm. Oh, now I'm saving to rerun the tests. That's funny. Let's rerun the tests. Aha! And it's failing for the right reason. Yeah, luckily in Kotlin it's a little bit easier to update stuff because we can just return a new position and only update the position and rerun the tests. Voila. Okay, then I guess the next test would be to, when receiving forward and rover is facing east, then X is increased. So we expect only X to be increased. But now we need to say, I want to create a rover facing not north, but east. East doesn't exist yet. It does now. And then this, I think I will rename to facing, because then it just reads rover facing east. It's much nicer, huh? And then this test should fail. Noise. Yeah, and now we just need to fix that. So we still need to check receive forwards, and we can just check if facing equals north. Well, then return the thing we already had. Otherwise, we can just bump X. This should work. Ah yeah, we can say lift return out of if. Oh, it's still not working. Ah yeah. Reason for that? No, I don't get it. Oh, the test was just incorrect. Voila. Okay. Yeah, you can see where this is going, of course, because when receiving forward, now I'm stuck with fixing all of the different combinations. And maybe what we can already do in this case is add or make this into a parameterized test, where we say I want to, maybe let's do it like this. I want to get two arguments maybe. One would be the facing direction, so the direction, facing direction. And then the other thing would be the new position, so new position, which is a position. And then what we can do is we can compare that. So here's the new position, and both of these need to be the facing direction. And then all we need now is something that supplies us a combination of so for example, north would be at 0.1, east would be 1.0, etc, etc. So these combinations we need to provide. So we can do that, I think, with the method source or something. And then a method source takes what? A string argument. So these would be the forwards. I don't know, pairs, cases, I don't know, forwards cases. So let's create a new function. Oh, IntelliJ is also saying, oh, nice. Apparently we need that. And then a stream apparently. Oleon, why? So that would mean returning, maybe let's just make that into a list first and then do a toStream on that. So arguments, I don't know what that looks like. Can we not just return tuples or something silly? Pair. I want a pair of the direction, so that's for example north, and then position 0.1, and we want to return this and then toStream. Okay then. How do you create this as an argument then? Can we mop it first maybe? Mop argument. Aha, arguments of and then it. Okay, I'm curious if this is gonna work. So if we add some more cases here, so we'll add east as well with a 1 and a 0, and then at least both of these should be working. And we should be able to remove this one. Very curious indeed. Ah, yeah, okay, that's correct. So maybe you can take variable arguments. It's either that or passing a pair as a single argument. So that would be a case of a direction and a position. And then we need to destructure that into a facing direction and a new position. I think this should work then, but probably there's an easier way to do it. Yeah, and so that works. And I think the other way that also would work is if we don't destructure, but we keep these, but then we'll need to do it.first and it.second. But then you sort of lose type safety, because now you cannot express. So if I do it the other way around, if I do it.second, I don't know, by mistake, I don't know, I make mistakes. Yeah, but in neither cases you would get you wouldn't get any feedback. Yeah, fuck. Okay, anyway. Let's add the other cases then. So that would be in south and then west. Neither south nor west do exist yet. So let's add those. And then they need proper things here. So west is definitely -1. And here it's -1 on the y side. Let's add an import for those. Sure. Okay, voila. Now if I run my tests, then at least all of the directions will have been covered with a parameterized test. Bam, bam, bam. This one, it ain't working. And neither is this one. Cool. So let's do the implementation properly then. By turning this into a when. Yeah. So we've got north. Then you can maybe. Let's do that. This would be east, and then we've got the other ones. So south and west. 0, -1, and then -1. We rerun the tests. We're Gucci, yeah? Oh, okay. I think that's about it for refactoring, I think. I also wonder if you... Yeah, I don't think you can move this one out of the test, in fact. I was wondering, because it's a bit cluttered now. It's only cluttered because it's in between my tests and my implementation. So ideally, I would have just moved that at the very bottom because I don't care too much about that, but I could also just do this. Well, yeah. That's okay, yeah? All right. Now, to do this in Elm, I have no clue. I think there is a way to do it though, to say, I want these cases. Because you've got this anonymous function here. And I bet you can pass some things here as well. But I don't know how you would do that. Maybe you can pass some things to test itself. Exposing fuzz. So it's a string. We've got that string and it's returning a test. And this is then the test. You can't actually scroll in there. Yeah, so I think what we want to do is we want to generate the tests because this is, as you can see, just an array of tests. So what we could do is just say create a list of different test cases, starting from those different combinations. So we can still do that. So if we just say forwards cases equals a list of, and then we'll do pairs here, or tuples I believe they're called. So we'll do north, comma, position 0, 1. In Elm you do that a little bit different, I think. And then you say east, position 1, 0, and then you say south, position 0, -1, and then finally west, position -1, 0. Neither east, south, nor west exist, but I think the moment, yeah, we don't have actually that yet. Where is north? Here. So this can be north, or east, or south, or west. Voila, that should at least compile now. Cool. Then those forwards cases we want to map into tests. I don't really know how to do that. Wacht, let's just create a new describe or something. And then we'll pipe in list.map to test or something forwards cases. And now we need to just write our to test mapping function. So our to test should look like this. It takes in a pair, so that's how do you say that? It's something that contains a direction and something that contains a position, and it should output a test. This thing, I think. And then we can just return so we do der pos or something. And then just as an example, let's try this one. Voila. Yeah, we can't actually translate direction yet, but so that would be here. And then here we want dir. And then here we want pos. So that becomes a little bit easier, huh? Voila. And now we no longer want the default rover, and now we want to set up a rover facing in a specific direction, but still at so that would be rover so position 0, 0, pipe that into a rover that's initialized with dir. And then this is the expected pos. I think we call that new pos or something. Voila, and that should be all of the receiving forwards cases, in fact. And now the only thing, if we want to make it a little bit more pretty, I think what we should do is translate this here or how does IntelliJ do that? North, it just returns the concrete cases that have been tested. Goh. This is so silly, young. Let's just try to translate it. So facing to string dir. Okay, I guess we'll have to put that into parentheses then. this function doesn't exist yet. Facing expected pos. ToString pos. Voila. And I would just need to write two different functions, ToString for a direction which outputs a string, and we want another one for a position to a string, and this one we'll say is a it's a case there, and then I don't remember. North. Oh yeah, this seems to... That's it, nice. Very generous on my bam. We just want to return this init. And then join lines, I don't know how to do that. Join lines, Control J, of course. Coolio, and then the ToString for position. And I think here, since position was also a record, we can already destructure that, and then we just say at plus x plus comma plus y plus the parentheses, and then both x and y we need to I don't remember what it was called. Is it int? So, and then we need to transform x and y into their string equivalents, and I don't remember how you do that. Is it int dot integer? No, it's int to string. Dang it. String from int. Ah, voilà. From int x. Okay. What's your problem, jongen? My Elm is very commanding, the Elm compiler. Rename one of them! Yeah, typically you solve this with a module. Because if you've got a module, then you can just refer to that. But I don't want to put direction and position into its own separate modules. It seems a bit overkill. Yeah. Okay. There to string and pos to string. Voilà ça. Oh. They be failing. Facing west, expected pulse. Well, at least our own made up parameterized tests are working very nicely. Yeah, because you can just use Elm to do that. That's really nice, actually. Yeah. Okay. So in our implementation, you know what? Maybe we should put the implementation somewhere else. In fact, fucking hell. Then at least we can make the distinction between test code and because it might turn out into something longer. Huh? Let's put that here. We don't need any of this. Voila. And we want to expose default rover itself, receive forwards. I'm not sure if you want to return get position. Ah, it is compiling, so that's good. And we've got failing tests for east, south, and west. Nice. That's a bit weird. We need to import main, exposing all of the things. Oh, we're not exposing position yet. And that should be it. Oh, and then direction, of course. It's not that I have to do something like this, right? I guess it was. Oakley dokley. So we've got failing tests, great. And now how to fix? Well, we go to main. We'll go into our receive forwards, and then what we shall do is our new position will depend on what the rover's direction is. So we say case. I'm not sure if you can do that. Case of rover dot facing direction. Nope, you cannot do that. Okay, then I think we're going to just destructure that shit, yeah. So that means we can do this facing direction and position, and then we no longer need get position because we can just use position. And then we also don't need to update the rover. We can just create a new one where we say a rover with facing direction. We don't want to touch that, but we want the new position to be updated. Voila, so that's compiling, but now we want to say case, not rover dot, but we want to go ham on this thing. I wonder what the problem is with this part. Yeah, north. Then it should be this. So east, south, and west. And for south we want to update y as well, and for west we want to update x as well. And the tests are green, yay! Yeah, this we no longer use, so let's clean it up, I guess. Cool, cool. Next part is a new test, I believe. So we've got forwards, but we're still implementing it in quite a lazy way, because our test just takes into account that our rover is always 0, 0. So what if our rover is no longer just at 0, 0? What if it's anywhere else? So describe when receiving forwards for a rover at 0, 0. And then let's just do the same thing for a rover at yeah. Maybe what you can say now is at any position. And in that case, what we should do is just say like initial position or something. Can we say that? I'm just afraid that I already have an implementation in my head. And my tests, or the way that I have to write my parameterized tests are already going to be the same implementation that I will have for my actual implementation. So that shouldn't be a good case, or a good way to write tests. Not really sure about it. Let's just try it. You know what I can do? I can change this into functions or something. Or I can say I expect my forwards case to be of a north. Well, if you're north, then this function should have been applied on a position. Is it cheating? It sort of is, I guess. And then we can still also use that implementation in our code, in our production code, I mean. Yeah, let's just try writing that. Then it's more generic. Oh, good lord. So we've got something that has an X and a Y. And we want to return X and then a Y plus 1. And then same for here. So we don't want to touch Y, but we want to bump X. Here it's the same, but with -1. And here it's the same, but with the X -1. All right, and then our, wait, something is wrong here. No, I don't get it. How do you format? Option Shift F. That somehow fixed it. Okay then. But now our two tests needs to change a little bit because they no longer are taking positions. They are taking in functions. Fuck, and I don't know how to... Something that has an X and a Y and are returning an X and a Y. Nee? Oh damn, I don't know. Is it we need to wrap this or something? Nee. Maybe it's a colon then. Yeah, okay. Position updater or expected position updated. I don't know. Updater hier ze. Okay. Oh, fuck. That we cannot just translate that, I guess. We could if we would apply. Oh, fuck. But we don't have a position. Yeah, we can create a position. So if we create a position of 0, 0, and we... Wacht, hè. So this... The post to string... is something... or takes the result of having the pulse updater being applied to a position of 0, 0. Position bump or something. Okay, and then we need to do the same thing here. Basically say do pulse updater. Maar ja, then do what? Oh yeah, shit. We can't just do that. We need our rover to be in a random position. And getting a random number in Elm is not easy. That's why you've got this kind of stuff in here. And it's still not compiling even. That I don't get. Oh. Yeah, opposition is of course just something that has an x and a y. So if I then have a function that takes in an x and a y and has these things applied to it, yeah, then why is this not working? Oh yeah, Junge, these goddamn parentheses. Okay. Oei. Oei. Now we're generating more than... Why is that, in fact? Yeah. This is why, of course. Okay, at least that's working. And this is a little bit different than I had before, because now I'm applying a function to the x and y, so it's a bit different. The only thing that's annoying now is this position 0, 0. If I just change this into whatever, then it's not gonna work because I'm yeah, okay. And it's always fixed. Okay, cool. I guess that'll just have to suffice. Okay, so instead of doing this implementation where we set it hardcore to 1, we should just say how to bump apply a vector of x0 and y1 to position, and then we have to do the same with all of these. So what does that look like? Apply vector. We can put that thing there at least. Yeah, and now we need to add position as a last argument. And then both x equals should have a y0. Ja, godverdikke, dat was te denken. Okay, no multi-cursor for me. Oh, 0. And here we want x to be 0. Huh? And an apply vector is something we're gonna write where we say this is something that takes in a position as represented by this vector basically, and we're returning a new position. And what we want to do, oh shit, I actually don't know. Apply vector, where v is the vector. Oh, and we need to do the p for position, so there's actually 2 positions. And we could just return p and then it would be compiling. But that's of course not what we want to do. We want to say update p, and then we want to say set x equal to, I think it works like that, and then y equals y plus v dot y. I guess we need x and y then, so let's destructure p. Let's just destructure that into x and y, and now we can just return it like this. Yeah, a miser. Okay. All right, and now we can just decide, is this good or bad? Maybe what we can do is make this into a vector, huh? And then we can just say type alias vector. It's the fucking same. And what we can then do is say I want a vector of 0, 1. And now maybe I wanted to read like that. Apply to position. Nee? It looks nicer, huh? One, 0. And then both of these will just multi-cursor so that become vector to this word. Goh. And now it's expand selection. Nee, that's not it. Oh. Control Shift. Dude. It works though. Okay. And then this can go. And then I need. Yeah. Yeah. It worked. Okay, and then this becomes apply to, and we just need to put the vector as a second argument. And also switch these around. Voila. Am I? And then what we could do as well is basically ask our facing direction to return us the vector so that that thing can get applied to position. So that would mean as vector for facing direction and pipe that into apply to on position. Oh, and we can even write it like this. Nice. So that will become new position. Eh? This is what I want it to look like. So then the first thing we need to do is transform our facing direction into a vector. We already sort of have that. So if we just remove all of these, here's our function that transforms a facing direction into a vector. And the cool thing about Elm is that you can even in a let in, you can write that. Yeah. Oh, there. Sweet. Hey, it's compiling and it's working, and now we just move that out closer to direction. And let's call this. Yeah, there is fine. Oh, Jesus. Let's type it as vector is something that takes in a direction and outputs a vector. Nice. Cool, huh? That looks quite clean now, huh? Now I was just wondering if we can sort of inline this. And we can if we say, but I don't know if I want that. because it might look a little bit ugly. So I say just do that. And then finally pipe that into a rover that already has the same facing direction. I'm not sure if I like this better. It's not clearer to me or more readable. With this, at least you know that you're creating a new position, huh? Good enough for me, young. Up, save. Let's go to Kotlin. Wait. Oh yeah, indeed. So in Kotlin, we're still also only hard coding at. Yeah, we can of course apply the same idea there, but then we need to make sure that we've got just any other starting position here. Yeah, then this might also turn into a function that updates a position. Let's try to work with that in a functional way as well. So I think we called it position updater. I actually don't know how to do that. How do you say? Let's just try to first write it as a function then, I guess. So what I want is something, maybe something that takes in a position. So we don't need that to say what it's like, but it should return a new position. So this is an updater then, huh? And position. Updater, and I want to supply the existing position, right? And this then becomes new position. Yeah, that's sort of how we need to do it. So in Elm we had the advantage that this now would not be compiling anymore. In Kotlin we don't. Well, maybe it's not Kotlin's fault. It's this fault, I guess, the parameterized tests. There might be a better way if we would have used Kotlin test, I bet, but don't know how to properly do that. If you do, please let me know. I'm here to learn. So we just need to change this to say this is an anonymous function that takes in a which is a position, which then returns At least I think that's how you do it. I want to return a new position where I say post.y. Oh nee, I can't do that. I need to copy it where I say y equals post.y plus 1. Something like that. Yeah. You cannot. Oh shit. So instead of doing it like this, I need to put that in a lambda. Yeah. Okay, that's better, eh? Ah. Sure, do I want to do that? Maybe not, eh? Bum. And now this is gonna be a way more difficult. No, I can't do that. I can't. Here it needs to be x. Here it's y, but it needs to be negative. And here it needs to be x. But it needs to be negative. Oof. Okay. It doesn't look better, but at least the squiggly lines are gone, eh? Apply to... Oh, you can't? Fix all. Okay. Yeah, sorry, you couldn't read it, but it was on my other screen. So at least if I run my test again, it should still work, I hope. Yeah, and now to make it look a little bit better, I think what I can do is I can write it as if it is an extension function. And what I can then do is I can say position updater. So, and if I run it like this, then it should still work. Noise. Okay. So if I just update my rover so that it has just at any other thing, and I run my tests, then they should fail. The output of the test name is now really shitty, of course, but I don't care. It's the expectation or the assertion that matters. All right, and now to implement receive forwards. So here again, instead of just returning an at, a fixed at, we can say position. Yeah, what's really cool in Kotlin is that you can say I want position to be added to this thing. So maybe what I want to do is to extract this thing first. So if I first assign whatever comes out of the when to my new position, and I then say return this.copy where I do position equals new position. And then here, instead of doing the copy there, I just return at. Now I can just say position plus, and that should return a new position. Because that's what we're really doing. We're just adding this here, which is a vector, to the current position, which returns a new position. And I then just copy a rover. Plus doesn't or shouldn't exist. I don't know why. So create member function plus. We call this other. It should return a position, and then we should just return this dot copy, I guess, where we do x plus other dot x and y plus other dot y. Or instead of doing copy, let's just return a new position then. And then we can make that a little bit more expressive like that. Again, saving, saving to get it working. And boom, it's working. That's great, huh? Can we make it better? I bet we can. Because in Kotlin we can do the same thing like we did in Elm, where in Elm we asked, hey, map our facing direction as a vector and then apply it to the position. We can still do that. What would that look like? That's a good question. Then we just say facing as vector. And then we would just say plus position, and that would be our new position. I guess to keep it, it should look like this then. The problem though is that our plus here is able to only, well, for now at least, it understands how to add two positions together, but what you want to do is you want to add vectors together to a position. So this should become a vector, and not that kind of vector, but another data class vector, which also has an X and a Y. And then, yeah. Maybe this can become towards or something, I don't know. Fun towards takes in an X and a Y and returns a vector of X and Y. So okay, and then we can run our tests because we changed some stuff. Noise. And then what we need to do is map facing onto the towards and then add it to the position. So that means that all of this can go, and then this would become vector, and then here we do plus vector. Or we can keep it. We can say val new position. It's a position, and we want to do position plus vector. So then we run this, and then finally we'll just ask facing direction to give us the vector. And then that part, I don't really know what the best thing is for that. I think I want it as a as an extension function. And I want it close to vector probably. Direction.as vector. And now you don't even see the towards, so I think I'll just inline this. It's nice, huh? And then we inline this part. You could also now say, well, if we do position plus facing, but that doesn't read that nice, huh? We could say, bah, I think it's okay. Let's run the tests. Yay. So we're not really generating that many tests, but that's, I think it's okay. All right, I am tired. Should I keep going? I guess we could do backwards, huh? That we're here anyway. So let's do backwards cases then. I mean, it's also the same thing. Oh, right. These tests no longer make any sense. So here's when we're receiving backwards. It's the same thing. Rover moves in the expected direction. And then that is determined by this position updater here. So now we, instead of receive forwards, we'll need to implement receive backwards. And let's just give it something completely different. And we need different cases here. So for backwards cases, if, yeah, it's the other way around. So our y gets decreased when we're facing north because we're driving backwards. So y gets decreased. Same for east. It's basically this part, but then flipped. Let's first make the tests fail by implementing receive backwards as receive forwards. Now if we run all of the tests, it should definitely fail. Ja, dat is goed, hè. And is it failing for the right reason? Oh, yeah, of course, because there's two difference. That's noise. So now we just need to do minus, I guess. Or what we say is plus, but then flipped. Yeah, that looks much nicer, huh? So what does it mean when it's flipped? Because I don't want to flip both axes. I only want to flip one. I don't think you can actually do that. Can you? I don't know, the vector, we can, because it will always be just 0. Nice. Okay, so function flipped returns a new vector where we just do this dot copy x dot negate. Is that a thing? No. How do you call that? Yay! I like this code, it looks great. Cha. And then the next part, I guess, would be because to a rover you cannot, I mean, the idea was to never really have a receive forwards and receive backwards functions. So what we should do next is basically say when you receive an F, then transform that into a forwards command and then apply that to your rover, and same for backwards. So maybe we can already write that in here as well. But I know we should first implement the backwards stuff into Elm as well. Huh? Then Elm is following. Okay, so our tests. We've got this part here. So it should read the same. We'll do backwards cases. So when receiving backwards for a rover. And then the backwards cases we don't have yet. And we'll do that. So. Yeah. And then the to test is basically always trying to do receive forward. So maybe we need to rename this as a forwards test. Receive forwards test. And then we'll do the same. I would say receive backwards test. So facing, that's fine. And now we just need to call backwards. And then maybe pass some different numbers here. I don't know. Receive backwards doesn't exist yet, so let's go to receive forwards. Just copy paste this one. call it receive backwards and then expose it. Yeah. And then we need to also save these tests. And then they should fail. That's great. Also failing with a 2 discrepancy. That's great. Okay, so our implementation needs to be what? So this is so cool. Now we can just say flipped and then apply to position as well. So now we just need to create a function that flips the vector. Flipped, which turns a vector into a different vector. Yo, where we say flipped, and we do x and y, and we just say x times -1 and y times -1. It's the same cheat, basically. Oh, dat gaat niet, of wat? Is it multiply? Maybe it's the problem with the... If I do this, then it might work. And then... So it was the formatting that screwed me over, or what? No, it's not working. Yeah, I don't know. It might not work this way. Flipped x equals x times -1. And we'll do the same for y. And then we'll just say this is flipped x and this is flipped y. Shit, it's still not working. Why not? So we say, take your facing direction. Pipe that into as vector, the function, which returns a vector. That output you should put into the flipped function, which then should flip the vector. So that would turn a 1, 0 into a -1, -0, I guess. And then apply that flipped vector to position. Assign that to new position. And then create a new rover with that new position. Oh. Okay, this explains. Godverdomme. Okay, then let's... can I inline? Is that a thing? So. Cool. It's funny how both solutions look very similar now. Huh? See, you can really just read it. Facing direction as vector flipped. Facing direction as vector flipped. And then, okay, apply to is a little bit different. We just use plus. Yeah, I think it looks nice. Okay. Then I suggest that instead of receive forwards, what we'll do is we'll write receive f. I guess we can keep this for now, but then our function returns into a command string. And it should return a rover. And currently it should just do this, because it's always going to be forwards. I saved again. It's so funny. But then if I now also implement my backwards tests as using this, then it's going to fail miserably. Explosions. Great. So we've got two cases now. What we can do is we can just do return when command string. Fuck, I don't know how to actually do that. Is it just like that? Ah, yeah. The else branch would be explode. Something like that. That should make it work, I think. But I sort of want both of these to go together, because the only thing that differs here is the dot flipped part. We could do that with the boolean, but screw that. I think this is okay. Let's make these private because this is good. Now, of course, F and B, they're not very explicit, so it can be really accidental that F and B is a So what I want to do probably is first map this into a known command and then have a different function called receive with the command, and that will then contain this bit basically. So let's think about that for a sec. So we will have different functions. A string parse to command function, which is going to return a command. A command doesn't exist yet, so maybe let's make it into what? An enum. That's all we need for now, huh? So we've got forwards, backwards, and those are the only commands we know for now. And what we can do is we can do this part here. We say return when, and then instead of command string, what the fuck? It's weird that it didn't find it in here. Then you should be command forwards, backwards, and then this can remain. Voila. Now we've got the command, and then we should just forward this. Say return receive with command string dot parse to command is save, and this should become another private function called receive, which takes in a command, which is a command which returns a rover, which is implemented like a when command, and now we just do command dot whatever forwards, then do forwards. If it's backwards, then do backwards. We don't need an else because it's exhaustive now. And now you can see we could now say our command understands how to apply itself to a rover. So then that even more so becomes return this dot command. Maybe execute or something. And then that will become something that you can apply to a rover, which returns a new rover. And then our commands are going to become these receive forwards functions. Something like that. Yeah, I don't know how well that is going to work, because we've always gone from the assumption that both position and facing are things you can ask from a rover. But what if we make them private, then all of a sudden you cannot do that any longer, eh? I mean, if I have my command as an external class, the thing is though, is that this part could be a private function within rover, and then yeah. How is that better than before, I guess, huh? The whole reason why we wanted to make this class command is so that we can then make real explicit which commands you have. And I feel like we're not doing that with this part. So I want to revert this part again, where I was gonna try to execute the commands, so to speak. Okay, voila. Now I wonder if you can move that in here. Oh, that's fine, nice. Then this should also move in there. And we want to make this a private function, huh? Now I'm just curious if what I was saying is correct. So if I make this one private, because that's one of them that we're using, and I basically say command as function or something should return a rover function that should return a rover, and then when this is forwards, then I want to return something that says a rover, huh? This bullshit. So we don't need that crap here. That's also incorrect. And then this dot copy is gonna turn into rover dot copy, where this is gonna become rover dot position, and same for rover dot facing as vector. Okay, this is a rover. Oh yeah, we need to return. Yeah, fuck. How do you... Return type of enclosing function to rover... No, I want this thing. Ja. Doe maar, ja. Continue. So this needs to be the return of the... Oh shit, I don't know how to do that. Don't return at all. Yeah, okay. Oh my god. But it seems like you can access private functions, eh? So even like that. Oh fuck. See, that's why it was a bad idea to update that. This is really complicated, I know. So my idea then was that what you can do then is just say receive would turn into return command dot s function and apply that to Rover basically. In this. So what you could then do is just say here as function. That would change the signature. Where you would then just do return this dot as function over command. This is such overkill, eh? Who can read all of this? Fucking hell. I'm glad that I tried it out to see how it would work. And that you can use private functions if you've defined your inner class as private as well. Yeah, so this is now being used again, and we don't need this as function thing anymore. Okay. My tests are still green, huh? After all of that bullshit refactoring. Cool, cool, cool. Okay. You know, I'm gonna extract this as a variable. Call it towards. I'm gonna do the exact same here. And then I'm gonna use extract method in the hopes that move basically on the IntelliJ. So in Java, IntelliJ would have recognized that both things are the same because the signature is the same. Wait, I think I've made a boo-boo. This is the thing I want to extract. Voila. Move. And now it's gonna recognize, hey, this is duplication. Yes, it is IntelliJ. You've seen that correctly. And then what we can do is just inline this. Voila. That's nicer, huh? All right, I'm gonna call it quits, Young. We've experimented enough. Yeah, in what's it called, in Elm, it would be exactly the same. We would just do string parsing on a string. And in reality, your strings really can look like this, in fact. In reality, I say. So that would be backwards, then turn left, then forwards, then left, then backwards, then turn right. So now it's just gonna say, I cannot understand all of these comma separated commands. So yeah, but that's for next time, I think. All right, thank you for hanging out and yeah, I don't know, keeping me company as I'm doing these code katas and both languages at the same time. It was quite interesting to see how similar these two languages are, in fact, or how you can make them look similar. Kotlin is definitely a lot like a functional programming language in this way, yeah. Or what I should say is it lends itself nicely to work in a functional programming way. Because I could have just as well implemented it with non-immutability. So, oh yeah. Okay, so next time, what I will try to save you guys from is SpringSecurity bullshit. I will try to just do that and then go over how I did it, because that's gonna end up being me just trying to figure stuff out all the time, which is, yeah, extremely boring, honestly, yeah. And then maybe I will have energy for this part. We'll see. Or we can just completely ignore all of this and then I'll do it in my own time at some point. And next time we're just gonna do this. A registered player can report a loss. Yeah, maybe I should do this first in my own spare time as well. Then we can just get to coding straight away. It's gonna be the most interesting part, I think, at least. All right. Phew. Okay. That should be next Tuesday. And I hope to see you then for more Kotlin and Elm goodness. And until then, have a nice week. Yeah, that's it. Have a nice week. See you. Bye. Peace.